Welcome, my fellow programming Rocketeers. Today, we're diving into the fascinating world of RocketPy's environment class, where we'll learn to unleash the power of Python for accurate weather forecasting. Get ready to take your coding skills to new heights. With RocketPy, you're going to make sure your weather predictions don't end up like this.
100 in Terrell. Right now in Terrell and in Dallas, your heat index is 107. Everyone in McKinney is dead. The temperature, the heat index right now in McKinney is 10,000. What is that? 101,105. It's hot in McKinney.
First, let's set our trajectory. We're going to start by exploring the incredible features of RocketPy's environment class. From the standard atmosphere to custom atmospheres, weather forecasts, reanalysis, wind.com integration, and even Ensemble models, we'll cover it all. Prepare for an epic coding journey to the highest grounds. We're going to start by pip installing RocketPy version 1 in case you haven't already. If you're using Jupyter notebooks, I recommend using the following line, matplotlib widget, just so you can show the plots from matplotlib and a higher quality. Here we're going to explore the environment class, so let's go ahead and from RocketPy import the environment class. We're going to start by using the datetime library, where we can essentially define an environment variable from the environment class using a specific date. Here, the time zone that we're using is America, New York, but we can use any time zone or leave this blank so we can use UTC. If we get the information env.info from this variable here, we can get the standard gravity, latitude and longitude as 0, as well as some standard plots for wind direction, wind speed, density, and speed of sound as a function of the height. Let's go ahead and look into the atmospheric models. Here we can use the standard atmosphere, where we're going to initialize the environment class without any parameters at all. That's going to use the International Standard Atmosphere as our baseline. So from the information, we don't get anything fancy for the wind direction, density, wind speed, and speed of sound. Here we can also set the atmospheric model as standard atmosphere even after we've modified our variable as much as we want. If we want to use a custom atmosphere with specific wind in different directions, as well as the pressure profile and the temperature profiles, we can initialize our variable here using the environment class. And we can set the atmospheric model as custom atmosphere for the type and change the pressure, temperature, and wind in the U, east, and V, north directions. Here we're not changing the pressure from the default, and the temperature is set as 300 Kelvin as constant with the height. For our wind profiles, we are changing in specific points. So at 0 meters of altitude, we have 5 meters per second, and 1 kilometer, we have 10 meters per second in the U direction, or east. Similarly, for V, we have specific heights and wind directions and speeds. Here we're going to get the information, and we can see that our plots changed a little bit with respect to the wind speed and the wind direction here. The density and speed of sound didn't change that much. We can also import CSV files from custom atmospheres. And if you want to look into that, take a look at our documentation for more. That can be useful if we have data from weather balloons or other sources such as sensors and rockets. Now, let's move on to weather forecasts and reanalysis. So that can be used in any atmospheric model, and we're basically importing global features such as GFS, as well as local forecasts. For reanalysis, we can use such as ERA5 and download that from the Climate Data Store website. So basically what we have is the standard, which is the simplest standardized atmosphere. We have the custom, which is specific and useful for modeling specific cases that are more controllable. You can also use the forecast, which is more refined and uses real forecasts, and reanalysis, which uses historical data when we don't really have forecasts for the specific location and time. Ensembles are more complex and take on many different profiles and is very useful for dispersion analysis. So let's go ahead and set up date, latitude, and longitude. If we import the datetime library and we set up the date as today plus a time delta 1 day, what we're doing is getting the date information from this variable, and we can print this out just so we can see the date information. And the environment variable is set up with this date info as date and specific latitudes and longitudes. Now we can also use a different approach where we set up the latitude and longitude, and then later we set up the date. That also works. GFS is a very useful forecast where we set the atmospheric model as forecast and use the file GFS to essentially get this data from the forecasts in real time. That takes a little bit of time to run. Now we can see the information that we got from this variable, and the gravity changes with respect to the height. And we can see that the wind speed, direction, and density, they all go haywire. And the wind in the U and V directions are also available for plotting. The temperature is also shown here, and we can see that it changes with respect to the height. If we want to use windy.com, that is useful for weather and atmospheric forecasts in any place in the world. So we're going to do the same thing here to set up date and time. And we're going to set up 4 different variables with all the same information: latitude, longitude, and date. Here we set up the atmospheric models, and we're going to use the type windy and different types of file for each one of these variables. And if we plot one of them, iconeu, all information, we can see that our plots are a little bit more complex, and they show different wind speeds and wind directions here for each one of these plots. Using Ensemble, forecasts and reanalysis can also be useful. So what we're going to be doing here is setting up the date time and using that as date info, setting up the latitude, longitude, and elevation, just like last time. Elevation can be useful for specific places or heights, and the atmospheric model can be set as Ensemble, and the file here is just a specific type of Ensemble. By default, the first forecast member, or number 0, is activated, which means that the variable is going to be using the exact same member as the 0th, while the other forecasts are kept away stored. We can also select a different member, such as number 1, and we can use this one to use the forecasts. If we get all info from this variable, we can see that the plots here are used with one specific members, but it also shows the members comparison between each other. That can be really useful for dispersion analysis. In this video, you saw how RocketPy can be used for weather modeling, from standard atmospheres to custom atmospheres and more refined models such as ensembles, reanalysis, and forecasts. You can see that even though it can be a little bit intimidating at first, using forecasts, reanalysis, as well as ensembles is actually pretty simple. I hope you enjoyed this video, and I'll see you next time for more.